watching how to conduct or to do analysis on SPSS, the predictive analysis. In our last video, we talked about how to carry out your predictive analysis using simple regression, but in this video, we're discussing on how you can carry out your predictive analysis on SPSS using multiple regression. So we are using the same data set we use for the simple regression analysis. We have the data set here. We have for the salespersons, we have for the years of experience, and we have that's the years of experience for the base year. We have the years of experience for the current year. We have the level of education, and we have the sales per salesperson. So, and this is expressed in dollars. So, in conducting a predictive analysis, it is very important for us to know modeling, mathematical modeling. And for a multiple regression, it means we're having at least two independent variables and one dependent variable. So in this sense, we have last year's sale as our dependent variable. We have the years of experience of the base year and the education level as our independent variables. So please, let's go to our SPSS and let's click on the analyze icon. Go to regression. We choose linear regression, and our dependent variable is last year sales. Our independent variables, we have the first, which is the years of experience, and we have the level of education. So now we have it already. So we can just click OK for the result to come out. So go to your output window. See the result of the regression already on the output window. We have the first results. We have the model summary. We have the value of our R squared. We have the value of our adjusted R squared. And we have the value of our coefficients of correlation. And let's talk about the R square. It's estimated to be 97. That's 0.976. That's about 97.6%. You can see from here that the independent variables in these estimates can explain about 97.6% of the total variation in the dependent variable, meaning that the years of experience and the level of education can explain at least 97.6% of total variation in the sales. We have the ANOVA result. We have the ANOVA result here, but let's go to the coefficients, which of course is what we use for prediction. In this, we have our T statistics, we have our significance level, we have the coefficients, we have the standard error. And from this, we can deduce that our significant level is less than 0.05, all for the constants and for the two independent variables. For the constants, we have 0.00. For the years of experience, the first independent variable, that's 0.00. And level of education is also 0.00, which means that from this part of probability value, that we can conclude that variables they are significant in the study, including the parameters are significant. So we can use the estimate here to predict for the future, and of course we need the coefficients to predict this, and of course because we have significant value, it's more acceptable to use the coefficients. And the coefficient of the constant is minus 8,510.838, and the coefficient for the years of experience is 1,874.5, and the coefficient for education is 609.391. So with this coefficient, we can predict for the future. So to predict now, we just go to transform. We compute variable the new variable that you want to predict. Let's call it new year sales. Now, before I type the normal code for predicting here, let me quickly write a typical mathematical model for multiple regression. We have y equals to a plus bx plus, let's say, cz. So because we have a, b, and c as our parameters, we have x and z as our independent variable, and of course y is our dependent variable. So just as we have it here, we can predict using the analysis we've just done. We know that our y is last year's sale, which is a dependent variable. Our x is the years of experience, which is one of the independent variables, and our z is the level of education. So we can just substitute the value of our estimation here to predict for the future. So now we won't be needing y here because y is what we are determining, and y here has been target variable. That's the target variable. So to replicate this, our a, which is our constant, was estimated as minus 8,510.838. So there's an addition sign there. Our b was estimated as 609.391. Now you notice there is a multiplication sign there. That's a x there. So x will still be part of this. Multiply, that's the normal multiplier sign. That is the shift key and letter 8. So give us a time, so you can just use the produced numbers here to get yours. And just now our b is years of experience, is level of education. Yes, that's 609, and of course the variable itself will be at the back. So this is the level of education. Just come here, click, then you transfer it there. So we have plus 609.391 multiplied by education, and of course our last variable, that is for the years of experience. So that will now be the coefficient of the years of experience is 1,874.5 multiplied by. Now we have years of experience for last year to be this, but because we are looking at another year which is forecast for the next year, predicting for the next year, so we need to use the next year year of experience. So we transfer the years of experience to the port there. So we have our equation here now. This is called the regression equation in multiple regression. So we have minus 8,510.838 plus 609.391 multiplied by education plus 1,874.5 multiplied by years of experience. As we've done this, just go to the OK. So now, for you to see the outcome of that prediction, you need to go to the data editor window. Now we have the prediction here. So from here, we can conclude that Achilles, which is the first salesperson, is predicted to have this product sales, total sales at the end of the new year, which is 8,081.7. That's his prediction. And for example, you go to the case 11 here, we have Becky. Becky is expected to have 18,109 0.9. So this is how to conduct and to carry out predictive analysis on SPSS using the multiple regression. Thank you very much. See you in our next video for more regression analysis.